Okay, so thank you very much for your kind invitation. A pleasure to have the chance to show you some of the work that I've carried out in the Maestrat Basin in the Eastern Iberian chain since my PhD thesis. I am Telm Bover-Arnal from the University of Barcelona, and today I'm going to talk about the sedimentary imprint of Aptian eustasy in carbonate platforms from Iberia. And mainly, I'm going to focus on the small outcrop that you can see in the image. The image is around half kilometer in width. It is a very small outcrop, but with a spectacular geology. This work has been performed together with Ramon Salas and Joan Guimarà, also from the University of Barcelona, and with Josep Anton Moreno Bedmar from the UNAM in Mexico. Here you have the aim of my presentation is to show you the sedimentary record of the aim of the presentation is to show you the sedimentary record of a major relative sea level fluctuation of Aptian age, which we interpret as mainly resulting from eustasy. Here you can see a paleogeographic reconstruction of the Titis during the Aptian. The Maestrat Basin was located here in the eastern Iberian plate, in the northern margin of the Titis. The Maestrat Basin was developed during the late Jurassic, early Cretaceous rifting cycle that affected the eastern part of the Iberian plate and was inverted during the Alpine contraction. Here you have a map of the Iberian Peninsula. Here we would have the Atlantic Ocean, the Mediterranean Sea, the Balearic Islands. Barcelona would be located in this point. Here, this is the Iberian chain, highlighted by this discontinuous line, and the Maestrat Basin is located here in the eastern part of the Iberian chain. This is the Ebro Delta that you can see here. During this late Jurassic, early Cretaceous rifting, the Maestrat Basin was subdivided into several subbasins, several depocenters that were bounded by major normal faults, but also by threshold areas, by topographic heights. Today, I will show you mainly outcrops from the western marginal part of the Maestrat Basin, from the Galvez subbasin, and I will show you another outcrop, a single outcrop from the Urpesa subbasin in the eastern part of the Maestrat Basin. This is the latest Barremian Aptian stratigraphy of the Maestrat Basin. The latest Barremian unit is the marine shelf formation. These are limestones rich in foraminifera with abundant orbitolinids, Palorbitolina lenticularis. Above, there is the early Aptian basinal marls of the Forcall formation. This is an alternation between marls, marble limestones, and limestones are distal deposits, are basinal deposits, very rich in orbitolinids, but also in ammonoids and nautiloids. And thanks to this abundant ammonoid record, we have been able to identify the 4 ammonoid zones for the early Aptian, also the limits. The ammonoid zones identified are here dashed in gray. So we have a very, very precise calibration of the early Aptian succession in this western marginal part of the Maestrat Basin. Above these basinal mounds of the Forcall formation, there are the platform carbonates with rudistant corals, like those that I'm showing you in the picture, these 2 small branching coral colonies. These are platform carbonates of the Villarroya de los Pinares formation. During the late early Aptian, a major relative sea level fall exposed superiorly these platform carbonates of the Villarroya de los Pinares formation and were incised. My talk will focus today on the Villarroya de los Pinares formation. Above, there is an alternation between basinal marls and platform carbonates, also with rudis and corals that belong to the late Aptian Benasal formation. During the late Aptian, these platform carbonates of the Benasal formation were also superiorly exposed and incised. However, I do not have time to show you the Benasal formation in this talk. If anybody is interested, we published a paper on the Benasal formation in 2014 in sedimentology, and another one last year, 2022, in global and planetary change. So today I will focus the talk on the early Aptian Villarroya de los Pinares formation, and as I've said, mainly I will show you outcrops from the western marginal deposit center of the Maestrat basin. So here you have a not to scale, a sketch showing a transect from proximal platform settings to basin for the later Aptian carbonate system corresponding to the Villarroya de los Pinares formation. Above the transgressive basinal mounds of the Forcall formation, there are Heiston platform top carbonates. These Heiston platform top carbonates pass laterally to slope deposits, and these slope deposits pass basinwards into the mouths of the Forcall formation. During the later Aptian, a major relative sea level fall exposed superiorly this Heiston platform, and there was incisions produced. There were incised valleys in the area of Camarillas, in the inner proximal parts of this carbonate platform. During relative sea level fall, a force regressive wedge accumulated at the platform margin in a basinal position. With a subsoil base level rise, accommodation was created, and a small prograding low stand downlapping over the force regression and unlapping the former Heiston slopes developed. And when the transgression started, the platform carbonate is stuck in a backsteeping fashion. It starts the retrogradation of the whole system. So this is the big picture. And now I would like to show you the platform margin. I would like to show you the rocks and show you this interpretation at the platform margin. If the computer shows the picture, I'm sorry because it is stuck. Okay, now. Okay, so here, the succession, you can see a limestone bed, which is horizontal. This would be platform top. Then this limestone bed is slightly inclined. This would be the prograding Heiston slopes. And note how these prograding Heiston slopes pass basinwards into the mouths of the Forcall formation. This is a carbonate platform that starts with a gradation, with a thick limestone bed, and ends with progradation. And the stratal terminations are in downlap. By definition, this is a Heiston system track and would correspond to the Heiston system track of the first depositional sequence A. Relative sea level fell, and during relative sea level fall, there was the accumulation of a force regressive wedge, also belonging to depositional sequence A. This force regressive wedge is bounded below by the basal surface of force regression that marks the start of base level fall at the shoreline, and is stopped by the sequence boundary that marks the lowest point of relative sea level. As a result of this relative sea level fall, this Heiston platform was super exposed, so there is a superior unconformity that passes basinwards into its marine correlative conformity. Now we are at the lowest point of relative sea level. With the still stand and the subsequent base level rise, accommodation was created, and a small carbonate platform that starts prograding and ends with a gradation, and the stratal terminations are also in downlap over the force regression, developed. By definition, a carbonate platform that starts with progradation, ends with aggradation, and shows downlap stratal terminations, it is a low stand platform, and would correspond to depositional sequence P. It is the low stand of depositional sequence P. Above, there is the transgressive surface. Note how the transgressive surface superposes the sequence boundary towards the land. So there is a superior conformity superposed by the transgressive surface, forming a composite sequence boundary. And how, basinwards, this composite sequence boundary, it is subdivided in the correlative conformity below the low stand and the transgressive surface above the low stand. Above the transgressive surface, the system is stuck in a retrograding pattern. There are backsteeping platform carbonates that pass basinwards to the mounds of the lower part of the Benasal formation to basinal mounds, but also upwards in the succession after the platform carbonates were drowned. Above, there is the maximum flooding surface of depositional sequence B at the downlap surface of the next Eustasy platform top carbonates with rudist and corals that belong to depositional sequence B and to the Benasal formation. So this is the big picture. This is the model, and now I would like to show you details of this platform margin of Las Mingaches. Is the area of Las Mingaches. I will start showing you the Eustasy platform. Again, you can see here that the limestone beds are horizontal. Then these limestone beds are slightly inclined, and these prograding slopes pass basinwards into the basinal mouths of the Forcai formation. This is platform top, these are the slopes, and this is basin. And note also how this carbonate platforms starts with aggradation with a thick limestone bed and ends with progradation, and how the stratal terminations are in down. Therefore, it is a Eustasy platform, is a Eustasy normal regressive unit of depositional sequence A. Relative sea level fell, and here we are not seeing the force regression or the lowstand because this is not a deep view. This is an oblique view. So the force regression and the lowstand are found basinwards in a southwest direction. So now we are at the lowest point of relative sea level. With the still stand, we had the formation of the lowstand in a basinal position, and with the transgression, the transgressive surface superposes the superior conformity towards the land, and above this transgressive surface, there is the backstepping platform carbonates of the transgressive systems track of depositional sequence B. And now I would like to show you the faces of this Eustasy platform. How we start with the platform top faces, how these faces look like. These are mainly limestones with floatstones and rodstone textures, showing well-preserved ruddy shells and also corals in live position. When we move to the slopes, the carbonate of the slopes is carbonate that was shed from the platform top. It's carbonate that was resedimented down the slope. So everything looks very fragmented. Are mainly radstones with fragments of corals and rudist bivalves. And finally, the faces of the basinal faces that correspond to the Forcai formation are mainly malts, muddy limestones, and limestones with abundant palorbitolina lenticularis, with abundant orbitolinids, and also abundant ammonoids, nautiloids, and solitary corals, and other relatively deep water biota. So now I would like to show you in detail this part of the system, the force regression, the lowstand, and the transgressive platform top carbonates. Here below, we have the transgressive malts with ammonoids of the Forcai formation. The malts at the top correspond to Eustasy malts. How do we differentiate those Eustasy malts from the transgressive malts? Because at the upper part of the Forcai formation, the malts also include scattered shallow water components. They include fragments of rudist bivalves, fragments of permocalculus, of algae, fragments of corals that come from more proximal parts. So this is indicating us that the carbonate system, the Eustasy platform, is already prograding and is shedding shallow water components down to the basin. Relative sea level fell, and during this relative sea level fall, there was the accumulation of this basin flow component of this fourth regressive wedge of depositional sequence A, which is bounded below by the basal surface of pore regression that marks the start of base level fall at the shoreline, and is stopped by the sequence boundary, by the correlative conformity, which marks the lowest point of relative sea level. With the still stem and the subsequent base level rise, there was the development of a small low-stand platform. Note that this carbonate platform starts with progradation and ends with a thick limestone bed with aggradation, and how the stratal terminations are in downlap over this fourth regressive wedge. Above the low-stand platform, there is the transgressive surface that marks the start of transgression, and above the transgressive surface tests the retrogradation of the system, the backstepping of the platform carbonates that pass basewards to the two mouths and also upwards in the succession after drawing. Here is where we place the maximum fluiding surface of the positional sequence B at the downlap surface of the next high-stand platform top carbonates with rudistant corals of the positional sequence B. This is a zoom of the fourth regression. Here we would have the high-stand mouths of the positional sequence A. This sharp surface corresponds to the basal surface of our regression. Here you have a close-up view of this basal surface of our regression. These are the high-stand mouths. This is the base of the fourth regressive wedge with some bioturbation. And note that the basal surface of our regression, it is a sharp surface. The microfaces of the fourth regression, these are grainstones, are slightly cross-bedded grainstones with a sorting, a moderate sorting. It is made up mainly of orbitolinids, Orbitolinopsis simplex. Orbitolinopsis simplex does not occur below the basal surface of our regression. Also abundant oysters and also abundant intraclasts. Remember that when this force regression is being accumulated basinwards, the high-stand platform in the proximal parts of the system was super exposed and eroded. So there were a lot of intraclass parts of this eroded platform arriving at the base. Above these force regressive wedge, above these grainstone deposits, there is the correlative conformity, the sequence boundary that marks the lowest point of relative sea level. This is the top of the force regression. This is the correlative conformity, which is also a sharp surface. And above we have the downlapping slopes of the lowstand of the positional sequence B. Now I would like to show you the lowstand platform in this outcrop here. This is a very nice image. You can see below how the faces look very nodular. The faces look nodular because these are resedimented deposits. This is carbonate that was shed from the platform top. These are the slopes of the lowstand. And above, the faces look more massive. These are autochthonous to parautochthonous carbonates. These are platform top carbonates, and you can see that these are very, very thick bed, and this is the grabbing part of the lowstand. So here we have the slopes, the prograding slopes, and above there is the platform top with the gradation, which is also prograding above the slopes. This is the lowstand platform, and this is also a very nice example to show you that those Aptian carbonate platforms, at least from the Maestra Basin, also for the high stand that I've shown you before, they had no barriers, they had no rims, no reefs protecting a lagoon. So those platforms had no lagoons, were flat top, non-rim carbonate platforms. They pass directly from platform top down to the slope without any barrier. Here we are at the platform top, and we pass laterally into the slope. Here we are at the platform top, and we pass laterally into the slope. The platform margin would be located here, and there is no barrier, no rim protecting a lagoon behind. Platform top, pass laterally into the slope. Here we are at the platform top, and we pass laterally into the slopes. We're flat top, non-rim carbonate platforms. At the top of the lowstand, there is a transgressive surface that marks the start of transgression, and above the transgressive surface, there's the retrogradation of the system, the backstepping platform carbonates of depositional sequence B. Now, I would like to show you the faces of this lowstand platform and also the platform top transgressive carbonates. The autochthonous to parautochthonous platform top faces, they are mainly, again, limestones with rudis bivalves in live position. You can see here all these elevated rudis in live position. This is the Polyconitis hadriani species, and also colonial corals in live position. When we move down to the slopes, as you can see, the faces looks nodular, looks more chaotic. This is carbonate that was shed from the platform top, that was transported from the platform top. So we have a close-up view at the faces, and you can see that it's made up of fragments of ruddy shells, fragments of corals, fragments of gastropods. Everything is fragmented on the slopes. And finally, the faces of these retrograding platform top carbonates look like very similar to the platform top carbonates of the lowstand or the highstand. We also have well-preserved ruby shells, nerinate gastropods, chondrodonta as well, and very nice rod-like branching corals in live position. Now, I would like to show you the lowstand platform and the transgressive platform carbonates in a little bit more distal part of the system. This platform, this lowstand platform, is the same as this one and is the same as this one, but the beds get thinner because we are getting towards the base. So here you can see that the lowstand in this more distal part of the carbonate platform. Note that here you are seeing these prograding sigmoids. How this system and this platform starts with progradation and ends with a thick limestone bed with aggradation. This is a lowstand normal regressive unit. This is a lowstand platform of depositional sequence B. Note also how the stratal terminations are in downlap. Above the lowstand, there's the transgressive surface that marks the start of transgression, and above the transgressive surface, the system retrogrades. We have a backstepping platform top carbonates that pass basinwards into the basinal mouths of the lower part of the venasal formation, and also upwards in the succession after those carbonates were drowned. When we have a close-up view of this transgressive surface, it is a hard ground. It is a hard ground with the ferruginous stains and also borings made up by lithophysic fibrils. At the top of this transgressive platform top faces, there is the drowning. This is the top of the platform. These are the transgressive boring mouths above, and we have a close-up view at this drowning surface. It is also hard ground with a ferruginous crust and crusting oysters and borings made by lithophysic fibrils. Here's where we place the maximum fluid surface at the downlap surface of the next highstand platform carbonates with rudistant corals of depositional sequence B. So I have shown you what happened to highstand platform margin when relative sea level fell and rise again during the late early Aptian. This platform margin is called Las Mingachas. And now what we are going to do is to move landwards to more proximal parts of the system, to the area of Camarillas, where I will be able to show you the sedimentary results of this relative sea level fall and subsequent rise in more proximal parts of the system. And we are also going to be able to observe this composite sequence boundary in more detail. So we are going northwards for 6-7 kilometers to the area of Camarillas. This is a drone-based model of this outcrop of the Barranco de la Canal in the area of Camarillas. Below, you have the transgressive basinal mouths with ammonoids of the Forcade formation, and above, there are the highstand aggrading platform carbonates with rudistant corals of the Villarroya de los Pinares formation. You can note that the upper part of the Villarroya de los Pinares formation, the color changes. Here below, it has a more grayish color, and above it has a more orangish color. These two sets of arrows are marking stratal terminations. And these two sets of arrows are delimiting a huge truncation. This is a superior unconformity related with this laterly Aptian measured relative sea level fall. Note also that this unconformity, this superior unconformity, shows flats and ramps, and how the transgressive backfilling deposits, backfilling the incised valley, overlie the flats and unlap the ramps, unlap this composite sequence boundary. These are very, very shallow carbonates. These are tidally influenced grainstones that at some point during the transgression were drowned, and above this drowning surface, there are the basinal mouths of the lower part of the venasal formation, and above the highstand platform carbonates with rudistant corals of the depositional sequence B. The depth of the incised valley is around 50 meters, and this could be an estimation of the amplitude of relative sea level change. So we know that at least the relative sea level fell for 50 meters during the late early Aptian. Here you have another example. Below, there are the aggrading platform carbonates with rudist and corals of the Villarroya Spinares formation. These are Heiston platform carbonates. And note, again, how these two sets of arrows are delimiting truncation, a superior unconformity, an incision, an incised valley that also shows flats and ramps, flats and ramps, flats and ramps, and how the transgressive peritidal backfilling deposits overlay the flats and overlap the ramps. These flat ram geometries are interpreted to be the result of periods of stream cutting erosion and periods of lateral planation. Again, at some point, those shallow water peritidal carbonates were drowned. So here we have a drowning surface and above the mouths of the lower part of the Benasal formation. The preserved part of this incised valley in this outcrop is around 15 meters. Note also that the incised Heiston platform carbonates and the corresponding transgressive valley fill deposits exhibit similar deep directions. In non-significantly structured outcrops, such as this one, the bedding of the incised bedrock below and the backfilling peritidal strata above is nearly horizontal. Therefore, there is a non-angular stratal relationship above and below the incised superior unconformity. And therefore, this unconformity corresponds to a disconformity. Now, I would like to show you this composite sequence boundary in more detail. There is the superior unconformity where we can recognize paleokarst features. Here you have a detail of paleokarst infilling. And in those two images from the right side, you can see the composite sequence boundary. There's the superior unconformity with the paleokarst features below and a rock ground above. The superior unconformity is superposed by the transgressive surface, which corresponds to a rock ground with the ferruginous stains and borings made by lithophagic bites. Here's the same. We have the paleokarst features with these orange infillings below and the transgressive surface and a rock superposing onto this superior unconformity. The faces of these transgressive deposits of the positional sequence B, these backfilling deposits filling in the incised valleys. As I've said, these are energetic deposits. They show cross-bedding, also bidirectional sedimentary structures, herringbone structures. This is why we interpret these deposits as tidally influenced. And the microfaces are grainstones, are quite well-sorted grainstones with abundant oysters, abundant intraclasts as well, fragments of echinoids and fragments of corals as well. So now I've shown you the carbonate platforms that were superexposed as a result of this major relative sea level fall of late early Aptian age in the western marginal part of the Maestrat Basin. We have recognized similar sedimentary results and coeval results in several basins of the Maestrat Basin. I will show you only one example in the Orpesa subbasin in the eastern part, just to demonstrate, just to show you that these major changes in accommodation during the late early Aptian had at least basin-wide significance, had at least a regional significance. So this is the Orpesa subbasin. This is the Barranc del Garrofé quarry. These are aggrading Heiston platform top carbonates with rudist and corals of the positional sequence A of the Villarroya de los Pinares formation. And again, these two sets of arrows are marking a truncation that shows those flats and ramps, similar to what we have seen in the western margin of the Maestrat Basin, and above these incised valleys, which in this outcrop, this preserved outcrop is around 10 meters, was backfilled during the next transgression. Here we have the mouths of the lower part of the Benasal formation, and above Heiston platform carbonates with rudist and corals and chondrodonta of the positional sequence B, also belonging to the Benasal formation. So this major relative sea level fall had at least basin-wide regional significance. And note also that there's a non-angular stratal relationship above and below the incised superior unconformity, and thus this unconformity corresponds to this conformity. Well, which mechanisms trigger this fall in sea level? We have done an estimation of the amplitude of relative sea level change by measuring the depth of the incised valleys. We have said that it was around 50 meters in the area of the meridians. We could also estimate this amplitude of relative sea level fall and rise by measuring the difference height between the preserved part of the high stand of the positional sequence A and the top of the force regression. Of course, this is only an estimation because the phases of the high stand and the phases of the force regression are different and were probably sedimented at different depths. And moreover, the upper part of the high stand is missing due to recent erosion. But at least we can say that we had a relative sea level fall of tens of meters. During relative sea level fall, there was the accumulation of this force regressive wedge of this basin flow component, and we have identified ammonite specimens, Dufresnoya specimens, belonging to the Dufresnoya furcata ammonite biozone in the upper part of the mouths of the Furcate Formation, also in the distal slopes of the Lowstand platform, and also in the lower mouths of the Benasal Formation. So we know that this relative sea level fall and the subsequent base level rise and the early start of transgression occur within the Dufresnoya furcata ammonite biozone. So here we have the Dufresnoya furcata ammonite biozone. Here we have the incised platform carbonates of the Villarroya-Espinales Formation. According to the geological time scale 2020, the Dufresnoya furcata ammonite biozone span 0.4 million years. In other versions of the geological time scale, 2016, 2012, the Dufresnoya furcata ammonite biozone span 0.9, and in the 2004 version, I think it was 1 million years. So we can say, at least, that there was a relative sea level fall of tens of meters that occurred in less than 1 million years. Could be related to regional tectonics, of course. We are in a rift basin. Seam rift subsidence is always playing a role. We measure total subsidence curves for this western marginal part of the Maestra Basin, and the results were that there was a latest Barremian earliest Aptian episode of rapid seam rift subsidence, but during the late early Aptian and during the late Aptian, there was a period of a slow seam rift subsidence. The carbonate platforms of the Villarroya-Espinales Formation developed in this late early Aptian period of slow seam rift subsidence. Therefore, it does not seem that regional seam rift tectonics could have played a key role in triggering this late early Aptian fall and subsequent rise of sea level. Moreover, we regard these non-angular stratal relationships above and below the incised superior unconformity as an indicator for a eustasy-driven measure sea level fall and subsequent rise, because in a scenario where layers of rock are regionally uplifted 50, 60 meters without folding and tilting, exposed superiorly and incised, and then straightaway subsiding 50, 60 meters without folding and tilting, while marine deposition resumes, and this occurring in less than 1 million years or even in less than 0.5 million years seem implausible. Moreover, there are several reports around the margins of the Titis, also in the Pacific Ocean, also in North America, of major changes in accommodation around the boundary between the early and the late Aptian. So these changes in accommodation type shown you in the Maestra Basin could have had a widespread occurrence. Therefore, the widespread occurrence of major changes in accommodation at the boundary between the early and the late Aptian would be also in agreement with eustasy. So to conclude, a non-angular stratal relationship above and below incised superior unconformities is regarded as an indicator for a major eustasy-driven fall and rise fluctuation of sea level. Accordingly, the Aptian recorded a strong eustatic sign-on, and the laterly Aptian relative sea level fluctuation with a dominant eustatic contribution investigated in the Iberian chain had an estimated amplitude of around 50-60 meters and a duration of less than 1 million years. Thank you very much.